Hey, it's Mr. Jensen. I wanted to do a review of the notes for heat transfers. So the first heat transfer that we come in contact with in the notes is conduction. And conduction is the transfer of heat when particles are actually touching one another. So I have three different columns here that are representing three phases of materials. And our first one, because the atoms are so close in this column, this one is supposed to represent a solid. Our second column, because the atoms are a little bit more further apart, is supposed to represent a liquid. And my last column on the right is supposed to represent a gas. So conduction happens the best when atoms are the closest together. So that means that solids are going to be the best for conduction because the space between the atoms is so little. Whereas in a liquid, you have some decent amount of space in between them. And a gas, you can have a lot of space in between them. So in our case this year, we would say that solids are the number one conductors for the transfer of heat energy. The example that you would have experienced in your life is if you've ever burnt yourself. That would be a transfer of heat from a really hot source onto maybe your hand, and you got burnt. So conduction happens when things are touching, and the hot item transfers heat to the colder item. And solids for us are the best conductors of heat energy compared to liquid or gases. All right, another type of heat transfer is radiation. So radiation is the transfer of heat without a required medium. And I like to go over what a medium means first. So a medium, for example, if you were to write me some information on a piece of paper and then hand it to me, the medium you're using to get the information to me would be the paper that you wrote on. Another example would be if you're texting your friends, that the medium you're using to communicate is going to be your phone, or maybe use your iPad or your computer, etc. So radiation doesn't require a medium, which means it can travel through nothing. And where is there nothing? In space. They call it the vacuum of space. The vacuum means there's nothing in there, no particles. So the sun radiates sunlight through waves. These waves can be found on the electromagnetic spectrum. And so the sun radiates energy through space in the form of waves down to Earth's surface, where Earth's surface is heated from radiation, right? And so we'll check that out further when I do a video about the electromagnetic spectrum. Great. I saved convection for last because we have seen this before inside of Earth's crust in the mantle or the asthenosphere, where there's a heat transfer due to differences in density. And so the example we already know is the magma or molten liquid rock in the asthenosphere that's closer to the center of Earth, which is the hottest part of Earth. So when it gets close to the center of Earth, it heats up. And when it heats up, it moves up because hot, less dense material likes to move up. And when it gets up and away from the hot source of the center of the Earth, it then moves back down because cold, more dense material likes to move down. And the way that we usually see this is with a full convection current. This is how we've seen it in the mantle, where there's one convection current on each side, and one is going down and one is going up, causing different geological features on the surface of Earth. Now, this happens with air as a gas in the troposphere, as well as it happens in the mantle, but it's the same process. All right, so there's one thing I'd like to show you is a combination of all of them. And to do that, I like to draw a campfire. And they're happy because they're camping. So how could all three types of energy be in this area? So the person is going to be warmed up or feeling warm from the fire, and that's because the fire is going to be radiating heat energy at the person from the source or the hottest point of the fire. So it's going to radiate, which means it moves in waves towards that person. So the heat you feel from the fire, if you're standing on the side of the fire, is going to be considered radiation. Now, you're boiling water, which means that some of the water is really close to the fire. That water that's really close to the fire is going to be really hot and less dense than the other parts of the water, and it's going to move up towards the top. The water at the top that is away from the flames, or the furthest away from the flames, will be colder, and it's going to move down back to the bottom. That's going to be called convection. Finally, if this person goes and reaches out to grab the metal pot that we're using, that's a hand, and they burn themselves on it because the particles are touching, because the hot metal particles are touching the particles that make up your hand, that would be conduction. All right, this is my little cartoon to show convection, conduction, radiation, and my little review of the notes. All right, so have a good rest of your day. Thanks for watching.